All right, advanced math A, here we go. We've got 9-3-2 more systems of inequalities, because what's better than systems of inequalities? Yeah, more systems of inequalities. That's right. All right, so this one we've got an exponential function and we've got a linear function. So let's start with the exponential because it's first. And that sounds like a good reason. All right, so here we go. We're going to make our axes here. Let's do it right there. That feels really good. All right, so it looks like my A value, it's missing one. So the A value is 1 and the B value is 2. So I'm going to put my y-intercept at 1, and then my multiplier is 2. So 1 times 2 is 2, and 2 times 2 is 4, and 4 times 2 is 8. There we go. If I want to go backwards, I just cut it in half and get 1/2, then a 4th, then an 8th, then a 16th. All right, so this one says that it cannot be equal to, so this is going to be a dotted curve here. Oh, that's looking ugly. That's all right. All right, so there's my curve. Good enough. Next, okay, so we've got a linear equation. You got two options here. You can just graph it using your intercepts. For instance, I know that my x-intercept, if I cover up the y, the x-intercept would be 4. So 1, 2, 3, 4. Boom, there we go. And then if I cover up the x, that's my y-intercept. I'd divide by 4, and my y-intercept would be 1, which is also right there. So I could do that, or I could subtract x from both sides and get 4y is less than or equal to negative x plus 4. And then I could divide everything by 4. And I'd get y is less than or equal to negative 1/4 x plus 1, because I divided all three of these by 4. And you get the same thing, because here's the y-intercept, and then I go down 1 and over 1, 2, 3, 4. Or I can go up 1 and backwards 1, 2, 3, 4. Now this one it can be equal to, so this one's going to be a solid line. There we go. And we now have 4 regions that we have to pick from, because in a system, it has to work for every single region. So let's call this region A, this one B, this one C, this one D. Let's find the region that works for all of them, starting with the absolute or the exponential function. It says greater than, so greater than is these two regions right here, B and C. So B and C are the two regions that work for that one. On the linear equation, if we look at it in slope-intercept form, it says less than the line. So y is less than. Y is less than down here. That's B and A. So B and A work for this one. So what do they have in common? Region B. So that should be where my solutions are that work for my inequality and my exponential and my linear. Now I could pick a point in this region to see if it works. Let's just do that real quick. So a point in the region that works, let's do -2, +1. That's right here. It looks like it works for both of them. So let's plug that in. So I've got the point -2, 1. So let's plug that in. So I would plug in 1 for y, and then I'd do 2 to the -2 power. 2 to the -2 is 1/4. Is 1 bigger than 1/4? Yes, it is. So that's a solution for the first one. Now we plug in the same 2 into this one. So I'd plug -2 into x. I'd plug in 1 in for y, less than or equal to 4. So over here I got -2 plus 4, which is 2, and 2 is less than or equal to 4. So it works for that one as well. So now we have found the region, we've tested the region, everything is working perfectly and delicious. All right, 9-66. We've got a search and rescue going on here. So there is a hot air balloon and it's missing in the Pacific Ocean, we're going to use some information to narrow down a search area because the Pacific Ocean is kind of big. We don't want to search the whole ocean. So we're going to use this map here from our resource page to help us decide where to search in this ocean. We got 3 pieces of information. First piece of information. The balloon departed from the airport at the very northern tip of the Philippines, so up here. So that's where it left. And it was supposed to follow a straight path directly to an airport in French Polynesia. So there's French Polynesia. That's the path it should have taken. So would we be surprised to find the balloon on that path? No, we wouldn't be surprised about that because that's where it was supposed to be. So this should be a solid line between those two. So make sure I get right in the middle of these two. That looks about the middle. Oops. All right. I am not going to be surprised if I see that the balloon is somewhere around there. Now we can actually make an inequality from this. So I wouldn't be surprised to see it on there. We got a little bit more information. It says the last known location was at negative 1,100 near the Solomon Islands. So each of these is 1,000. So negative 1,100, negative 1,100 would be right here. So we have seen them below this line. Now, they probably started off on this line and they've drifted maybe a little bit over here. So we would not be surprised to see them below this line because that was the last known location. Okay, good to know. So my inequality so far for this, let's see, the y-intercept is here. That's positive 2,000. So I know that we would be less than or equal to, because we can be below this line. Let's see if I can find the slope. It goes down 1 over 2. So the slope is negative 1 over 2 x. And then the y-intercept is here at 2,000 because these are all in thousands. So plus 2,000. All right, so not bad. About half the ocean I don't have to cover now. It's helpful, maybe a little. All right, let's see if we can get it narrow down the search a little bit more. A pilot from a nearby plane reported, "We're on our way from Australia when we saw a hot air balloon sinking rapidly. I am certain that it crashed south of our flight path. When we left Australia, we traveled 2,000 kilometers north for every 3,000 kilometers east." All right, here's the airport in Australia. They went 2,000 north for every 3,000 east. So that's their slope. So they went 2,000 north, 1, 2, 3 east. 2,000 north, 1, 2, 3 east. 2,000 north, Kiribati. And then 1, 2, 3 east. All right, so there's the pilot. He says, we were on this flight path right here. And that's the direction that we were going. And we reported that it was south of the flight plan. South would be this direction, right? Down here. So it looks like they saw the balloon somewhere below this line. So to write the equation for this line, they're going to be less than or equal to, and then our slope was up 2 over 3, so 2/3 x. And then the y-intercept here is at negative 2,000. So if this was all the information that we would have had, we'd be looking in this area right here. Because this area right here with Fiji, Tonga, and Samoa, but not quite Vanuatu, New Zealand might be a good place to look for them if they're really off track. So it looks like in this section is where we would look for them. Okay, so most of the ocean is taken away now, so we don't have to look so hard. But let's see if we can get a little bit more information. A phone call was received today, and it says, I was a passenger on a flight that flew directly from French Polynesia, here, to Indonesia, here. All right, so I was on a flight that was going directly from one to the other. All right, so we're going directly between those two. Let's show their flight. So they're just going, they're just going on along. And they say that they looked out their window and boom, they saw it going north. North. That's above them. So this one would be y is greater than or equal to, what's our slope here? It looks like it's going down 1 and over 1, 2, 3, 4, 5. So down 1 over 5. And the y-intercept, there is no y-intercept because it goes through the origin right there pretty much. All right, so where should we look for the balloon? In here, around Samoa. All right, that's still a ridiculously large amount of water. Doesn't look like it, but that's a lot. But at least you don't have to check the whole ocean. So we would tell the rescue teams to look somewhere around Samoa, which is actually part of the United States. Did you know that? U.S. Samoa is one of our territories. So if you live in Samoa, you're an American, but you don't get to have people sent to you don't get to vote for like senators and people from, you don't get representatives, which doesn't seem fair. We should make Samoa a state. I think that'd be cool. But anyways, that's just me. Hawaii is up here. That's also part of the U.S. So Samoa is part of the U.S. as well. The more you know. All right, so there we go. We solved it. We figured it out. Awesome. All right, last three. We're just going to go ahead and do these problems. I think this will be okay right here. All right, first one. Y-intercept is 3. 1, 2, 3. Boom, got it. Slope, up 2 over 3. Up 2 over 1, 2, 3. Or I can go down 2 and backwards 1, 2, 3. It can be equal to, so that's a solid line. Got it. All right, so there's the first one. It's less than, it's going to be below this line. Second one, there is no y-intercept. That means it goes through the origin. Slope is up 2 over 3, so up 1, 2 over 1, 2, 3. So it goes up 1, 2 over 1, 2, 3. Or we can go down 2 and backwards 3. And what do you know? They are two parallel lines. So when we did a regular system with equations, when we had parallel lines, we'd say that there was no solution because they don't cross each other. But this is a system of inequalities, so it's still possible to get solutions. We just have 3 sections to check. Section A, not A and A, B, and C. Those are our 3 regions. So for the first one, it says less than that blue line. Less than that blue line is B and C. The other one says greater than the red line. That would be B and A. So what do they have in common? B. So everything in between them is a solution. What could we check to see if it's a solution? Well, we could check like 0, 1 and see if that's a solution. And it is. Next one. Very similar problem. little bit off there, but who cares? So we're going to go up 3, 1, 2, 3, and we go up 2 and over 3. Or we can go down 2 and backwards, 1, 2, 3. All right, there's our blue one. Red one. We have going through the origin, goes up 2 and over 3, or down 2 and backwards 3. All right, we got that bad boy in there now. We still have 3 regions. I'll just call them A, B, and C. All right, the first one says, this is the blue line. It says less than or equal to 3. So that would be, less than would be B and C. This one says less than or equal to the line. So less than or equal to this last one is C. So the only section that works for both of them is C. And we could test it by picking a point over here. Maybe we would pick this point here, 0, -1. We plugged it in, we should get an answer. If I plug in -1 here, I'd get -1. If I plug 0 here, I'd get 3. So -1 is less than 3. And over here, I get -1 is less than 0. So it works for both of them. Last one, same exact thing again. All right, same exact 2 equations. Turn them into inequalities. There's my blue one. Bing, bang, boom. Got it. Red one goes through the origin because the y-intercept is 0. Then it goes up 2 and over 3, or down 2 and left 3. We got A, B, and C. This one, the blue one, says greater than the blue one. So that's only section A. This one says less than, and less than is down here. That's only section C. There's no shading because there's no solutions. They don't have any regions that work for both of them. So we would say no solutions. There's no regions that work for both of those inequalities, so therefore there are no solutions to the system. The end. All right, guys, math hard. See you later. Bye.